Okay. 11 people, 12, 13 in the meeting already. Sounds perfect to start. Just a couple of introduction slides before we get into the topic. We, as always, want to inform you that the meeting is recorded. So if you do not consent to being recorded or any of the chat log being recorded, please feel free to just watch the recording afterwards. You can watch the recording via one of our channels, the Power Platform User Group YouTube channel, and you'll find the links on LinkedIn, Twitter, or the Meetup channel. So if you haven't subscribed yet, please feel free to do so. To the administration of this call, I'm hosting this, Augustine is hosting this together with me, and we're doing this on a weekly basis. If you haven't seen one of our videos yet, or haven't had the chance to connect, and weekly when we are inviting some of the best speakers, and we're glad that every one of you is connecting every week to see those interesting topics that we're presenting. You can add us on LinkedIn. The LinkedIn handles you'll find on the slide that I'm sharing. So please, after, just reach out to us if there's a topic that you want to talk about, or just to connect. Feel free to do so. And with that, I'll end the boring part and hand it over to today's speaker, Mara Pereira, with Power BI Performance Made Easy.
Thank you very much for the introduction, and hello everyone. So my name is Mara, and I'm not sharing my screen. I should be sharing my screen probably. Okay, I'm going to share my screen first before I actually start talking. Okay, and let me get my slides here. And I'm not going to bother you with, is everyone seeing my screen? I'm going to assume you are until someone tells me otherwise. So, okay. Okay, so again, hi everyone. My name is Mara. And today I want to talk to you a little bit about Power BI performance and obviously everything around performance optimization. And I also want to share with you, or during this presentation, I'm going to share with you a specific use case. But I don't want to spoil you with the topic, because I have one slide explaining everything that I'm going to talk about. So I'm just moving on to the next slide, which is a little bit of an introduction, very, very little of myself. Okay. So again, my name is Mara. I'm a cloud solution architect at Microsoft, but I focus mainly on Power BI. I'm a data and AI cloud solution architect focused on data and AI. And for those who don't know me, I also have a blog, which most recently became a kind of a company. So I'm also the founder and data analytics lead of my new company now, which is called Data Pairs. And by the way, I will be leaving Microsoft tomorrow to focus solely on this new kind of business venture. But so far, I'm still a Microsoft employee. So anyway, moving on. Today, we are going again to talk a lot about performance. And the reason I want to talk to you about this topic is because you probably heard this before. If you work with Power BI, you've heard this before, like the data takes forever to load. Refresh is taking forever, and you don't know what to do about it. You don't know where to start to look for the problem that is actually making a report performance bad. So you have probably a lot of blog posts, you have a lot of books. I think you even have a book now, an entire book just about Power BI performance optimization. The thing is, it's probably a bit hard to digest all the information that you see online. And I get you, because even for me, sometimes it's hard to digest all that information about performance that exists online. So that's why today I wanted to focus specifically, or in this session, I wanted to focus specifically on one use case that I worked on. And the use case is all about how I went from a 4-hour kind of refresh to 30 minutes. So I'm going to talk to you about all the steps that I took that allow me to go from this very big, imagine that more than 4 hours refresh, I think, to only a 30 minutes kind of refresh. So I'm going to talk to you about how do you find out the bottlenecks for your performance. By the way, this is all about importing. This is, again, I'm not going to talk about all the different kind of performance optimization techniques that you have, because, again, there are loads of them. This is like specific things that I've done that I use to improve this specific report or this specific data model. So now, of course, you're talking or you're asking, what is the data model? And the data model is not that complex, as you can see here. Let me get my laser pointer. So the data model is not very complex at all. And I just want to say a note and a thank you to my now ex-colleague from Microsoft, because she left Microsoft, Rebecca, which I kind of reused one of her data models. This is all open data, so but I reused her data model to the session. So thank you, Becky. But anyway, as you can see, the data model is not very complex at all. You only have like 5 tables and just a little bit of an overview on what these tables are. This is, like I said, open data that you can easily find online. It's about crimes. Not a very good topic, I know, but it is about crimes. In this case, you have the street table, which has the information about the crimes, like the crime type, the date, where it happened, and so on. You have the outcomes table, which is basically the outcomes of those crimes, if the person was arrested or if he or she got a warning. You also have some stop and search data, just usually when police stop people, just to do a stop and search kind of operation. We have that table with that information here too. Of course, we have a date table, and also we have this kind of geospatial or table with the geospatial information, like the counties, the areas, the cities, and so on. So this is my my little data model, and probably you're asking yourselves, how did you manage to make a refresh that lasts 4 hours with these 5 tables? Good question, but we will get there. So the first thing that I want to talk about is, again, the case here is the report is the refresh, it was very slow. All the data was imported, and again, refresh, very slow. So the first question that I asked myself was, what is the problem? Of course, here I kind of knew that the problem was the data model, because we kind of developed the data model, so it would be bad in a way. But the problem in my head was like, it's either the data source or the data model. Of course, like when you're talking about Power BI, you can have other types of problems that are influencing like the refresh performance. Like you can have like a gateway problems. You can even be like the tenant itself. So you can have other things that can influence like your data refresh performance. But in this case, let's ignore that you have data gateways and all of that, and focus on only your imported data, your data model, like in Power BI desktop. So when I look at that, at that data model, I think, okay, this is either the data source or the data model. My data refresh is taking forever, and I know it's one of these two things. So the thing is, how do you actually find out which one it is? That's a good question. So there is this tool built by Phil Seamark. He is actually a program manager in the Power BI CAT team. And this is the tool I use to analyze, to do that analysis and to basically find where is the bottleneck. Is it my data model that is not very good, the data model that I built in Power BI, or is it actually the data source that is slow and making my refresh slow? So with this tool here, I'm not going into a lot of detail in this tool, like how you actually make it work, because there is an entire like blog post that Phil wrote, and you can go and search, do some Google research and find that blog post, and it has all the steps of everything that you need to do to make this tool work. But anyway, I'm just going to explain like what it shows and how I used it for this specific use case. So in this case here, you have the three most important things are this chart here, this bit here, and this little table. So the first thing that I look at is the refresh duration. In this case, I think this was a screenshot that I took from the post itself. So of course my refresh was 4 hours, not 37 seconds, unfortunately. And so this is one of the kind of the indicators that you can use. Of course, you kind of know already how long it took when you do the refresh, but it's still nice to know exactly how long the refresh took. There is just one thing though, you do need SQL Profiler to make all of this work. It's not just a Power BI template, by the way. But again, everything is on this blog post by Phil. The most important thing for me to find out what the bottleneck is for my refresh is this chart here. You have here this part where it says execute SQL, which is everything in blue, and process, which is everything in yellow. And here you can figure out what is your problem, because the execute in SQL, the yellow bit, if you have like a lot of, not yellow, sorry, blue, if you have a lot of blue, then this is the time the data source took to process the data. So a lot of blue means the problem is the data source. If the problem is your Power BI, you will see these yellow bars that will be a lot bigger than the blue ones. Or maybe the problem might be both, which probably is the case here. But anyway, the idea here is you can check where is the bottleneck. Is it the data source? Is it your data model? And in this case here, in this example, you can see that the problem was the data source, probably because you have a lot of blue. So you probably should be looking at your data source first before you actually go to your data model and try to do all these crazy things to find out what's happening. So here in this example, go look at your data source. But again, in my example, might be a little bit different, but this is a very nice tool to basically figure out where you should be focusing on. So, and that's exactly how we are going to use this tool. And you can also have like some other kind of information here in this table. You have how many rows per second were processed, how many rows were read, the duration, and so on. So you can have other metrics. You can even check like which table is taking longer to load, basically. In this case here, these first ones are taking, or it doesn't process a lot of rows per second. So yeah, this, for example, these three tables are not very good. But anyway, let's jump for to my example, which is this one. This is, I used again this tool on that data model that was performing really badly. And what I've done, again, I checked, it's taking more than 4 hours to do that refresh. And here, as you can see, everything is yellow. So I knew straight away, doesn't matter like what I have in the data source, what I have to look at is what I have in Power BI, because this is telling me that Power BI is taking a lot of time to process that data model. And you can even check here, like basically the slowest tables and so on. So here, at least now I know where I should be focusing on. I don't care, not that I don't care, but I'm not going to look at my data source because clearly that's not the problem. So there is kind of no point. If you want to solve like the main issue, you have to look at your data model. And that's exactly what I did. And again, you have this table here that allows you to do a little bit more like a deeper analysis of your results for your refresh. And in this case, I notice here I have all these local date tables that I don't even use because I have a date table. So I was like, okay, maybe I should look into this. I will look into this a little bit better. So I'm going to present a lot of different tools today. So I'm sorry in advance, but they are all very useful. So I think they are very worth mentioning. So I wanted to look in more detail at my data model. I know I should be looking at my Power BI data model, and I know that definitely have to look at this local date table. So I went to DAX Studio to check what was happening in more detail. And in DAX Studio, if you connect to your Power BI report, you can go here to this view metrics icon, and it will show you a table like this one. And you can see like the biggest tables. You can see it here. You can see the cardinality, the table size, and a lot of other stuff. And you can see this not only by table, but you can see this at the column level. So you can expand this and see for each one of your tables what are the columns that are taking more space, basically. But in this case, I didn't want to go to the column level just yet. I just want to analyze in general what's happening like with the tables at the table level. So again, I can see this local date table is indeed here, and it's taking like 50% of my data model, which is a lot for something that I don't even use, because I have, again, this date, this dimension table with the dates. So I don't even use this local date table. So for those of you that don't know, this local date table is a thing that Power BI generates automatically. And in this case, I found out that Power BI was generating like loads of dates because we had a date in our data model, which was something like year 9,999, which sometimes happens in real life. So what Power BI does is it generates all the dates in this local date table. It generates all the dates until until the year 9,999. Just a bit useless because I don't even need that. And if you're asking yourselves, you could just clean the data and remove that year 9,000 something. Yes, that's another thing that you could do, but I was lazy, so I went for the easy option. And the easy option is going to your Power BI options and remove this time intelligence tick here, which is usually enabled by default. It's that thing that creates all the hierarchies, like the year, quarter, month hierarchy, and so on, and also create those sometimes huge local date tables behind the scenes. So this is all I did. I didn't have to change. I didn't even look at my queries yet. And all I had to do, or all I did at this stage, was just disable the auto date time in the time intelligence functions here in the Power BI options. So I was like, this felt like this guy here just controlling time in a way. So what happened now to my data model? If you remember, we had 260 something minutes, and now just by disabling that little option, I managed to go from 260 minutes to 140, which is almost half. And we improved the refresh by 2 hours just by removing a tick. That's all I did. I didn't do anything else. So this is just to show you that sometimes it's little things, sometimes we go all crazy and try to improve our report performance, and sometimes it's just the little things. Again, depending on the use case, sometimes it's not this simple, but sometimes it is. So this is just an idea of the things that you should be looking at when your performance is not that good. And sometimes it's just a very simple thing that you need to do to improve it a lot. But I was not happy. I was still not happy. For me, this is like 2 hours and 20 minutes or something. It was still a lot, and I didn't like it. So I tried to dig deeper, and I went back to DAX Studio, and I checked again what was taking a lot of space. And now, as you can see, all those local date tables disappeared. Good, because that's exactly what we wanted, and we saw the effect of that in the timing of the refresh. But still, I have this street and outcomes table, which still take a lot of space. And I was like, okay, maybe I can do something about it. But I knew there was something called query folding. And before I actually look into the details of the columns of these tables and so on, I was like, let me check query folding. Let me check what's happening. So for those of you, again, that don't know what query folding is, I have here, I used a definition that I love from, I can't even see it, Accelerator BI, yes. And I love this definition because it's so simple and it's amazing. It's the best definition of query folding that I've ever read. So the term query folding refers to the process of taking complex tasks generated by Power Query, such as sorting 10 million rows of data, and pushing those tasks back to the database for the execution. And this second part is the part that I love, which simplifies the process so much. I like to think that Power Query is writing down some SQL code on a piece of paper, folding the paper in half, and giving it to the database as some kind of set of instructions for it to execute. So think about it like that. I think it's the perfect, like the most simple explanation of what query folding actually is. It's putting everything on a piece of paper and telling your database, please execute this for me. So those transformations are done on the database side and not on Power BI side. And ideally, that's what we want to happen. We want to push as much of the transformations to the database as possible. So we want this query folding to happen. That's why I knew that sometimes when query folding doesn't happen, it's not very good, and it can really make the refresh times increase a lot. So that's one of the things that I also looked at in my data model. So you're probably asking now, okay, but how do I check query folding? Like, how do I see that? Like, where do I start? So go to your Power BI desktop file and open your Power Query editor. So when I open my Power Query editor, I have here a few transformations, which are even not that complicated. It's just like 6 transformations. They look very basic. So for you to check if the query folding is happening, you can do a simple thing. That is this: if you right click on any of the steps, and you can see here if this view native query is grayed out or not. But unfortunately, this is if it's grayed out, it might not actually be true, and I will explain what I mean with this. So this is one way of checking if this step is being folded or not. So if this view native query is grayed out, it generally means that this step is not being folded. So it's not in that piece of paper that goes back to the database. But again, this might not be always true. Sometimes this might be grayed out, but the query folding is happening. Don't ask me why. I don't have a good explanation for that, but that happens sometimes. But it's a good way. And because of that, because I know that sometimes this might not necessarily be true, even though most of the times it is, I have another trick, another hack to check where the query folding is happening or where it is breaking, and so on. So what I do is I take everything that I've done on Power BI desktop in the query editor. I go to my query, I copy that M code, which are like the transformations that I applied, the code with the transformations that I applied in my query. I go to data flows, which is basically the kind of online version of Power Query. I create a new blank query, paste my code there, and then it gets all whatever transformations I have done in the Power BI desktop. And the magic of this is, as you can see here, you see a little blue. I think this is blue. I'm not sure. For me, it's blue. But anyway, you have this blue bar, and then you have this red one. So if you hover over it, you can see in the blue step, in the steps that have this blue bar, you can see that this step will be evaluated by the source. So this means that it's being sent by the source. It's in that piece of paper. So the source is taking care of it. But if you check the red ones, you can see this step will be evaluated outside of the source, which means that Power BI will be doing this work that is inside the steps here. Power BI will be doing these transformation steps itself. It's not going to be sent to the database. And this is not what we want again. So I looked a little bit further and I checked that this filter rows is being done like as the last step, the last transformation step. And I'm like, okay, so this means that these 2 steps here are being sent to the database. Good. But these 3, are not. And Power BI has to do it himself in a way. but you're filtering rows in Power BI, which means that you're bringing the entire, like all your data inside Power BI and then applying these transformations over all your data. And then you're filtering your data in Power BI. And I was like, why don't I send this to the data source? Maybe if I switch this step here, because I know the filtered row step can be folded. If I switch this, maybe I can take this filtered row step and put that in a piece of paper and send it back to the database. And if you're asking like, okay, but if this can be folded, why is it red? Because the problem is this change type step, it's the moment where the folding breaks. So anything after that, any transformation that you apply after that will not be folded. It doesn't matter if it can actually be sent to the database or not. From the moment you break it, it's done. Everything that you do after that will be processed in Power BI and will not be sent back to the database. So that's why, again, this filter rows, even though it can be folded, it's not doing that now because it is after the break, so it doesn't really work. So I thought maybe if I put this here in the middle of these two, maybe I can change this. So that's exactly what I did. I changed the step and put it in here where I know it will be folded. And you can see it changed. Now it changed from red to blue, which means that, okay, I managed to write that instruction in my piece of paper to be sent back to the database. So it's exactly what I wanted. So now this work will be done on the database side. And when it gets to Power BI here in these two steps, everything is already filtered. So I will be working on less data. Or Power BI will be trying to do its transformations, but on way less data because I did filter a lot of data in these filtered rows. So that's good. But now let's see the impact that this query folding thing and changing the steps does to your refresh. So as you can see here, we went from 142 minutes to 62. It's less than half. So again, it was a very little thing that I did. I just moved the step up. That's it. I didn't do anything else. So you can see little things, little changes can really make a huge difference in the performance of your reports. So again, another little trick: data flows to check the query folding, and then try to see if you can kind of tweak it a little bit and change the steps, because you should try to apply all the steps that can be folded in the beginning, so that they, again, because if when you break it, it's done. So try to put that in the beginning of the transformations, like as the first transformations, and everything that can be folded, leave it to the end. That's kind of the general rule. But still, I really thought I could do better. But again, just to summarize, this was our original refresh time. I disabled auto date time a tick, and I almost reduced the refresh time by half. And then I just tweaked a little bit my transformations so that I made sure that everything that can be folded is folded and being sent back to the database. And I managed to go from 142 minutes to 65 minutes, which is amazing. But again, I really thought, I still can do better. So I went back to DAX Studio, my favorite tool, and now I went to the column level. So I checked my metrics, and these tables are still taking a lot of space. But now I wanted to go one step further. I wanted to check, okay, but in this street table, what is exactly influencing this? Like, what column is taking the most space, basically? And I checked that this crime ID was taking 40%, is like representing 40% of, is taking 40% of my kind of data model space. And I'm like, this doesn't look correct, which is 78% of the entire table. A lot, right? And I didn't even need this in the end, because the report, imagine the report you're trying to build, you have an ID here already that is being used like to do the relationships and so on. And it didn't even need this crime ID. It was not being used anywhere. So what I've done here is I checked all the columns, and I focus on the ones that, like the quick wins or the low-hanging fruits, the ones that I was not using. They were taking a lot of space, and I'm like, I'm just going to remove those columns because I don't need them. So that's exactly what I did, but I didn't do this only for the street table. I checked it for the other tables, and the biggest columns and the ones that I was not using, I was like, I don't need them, so bye-bye, they are gone now. And again, just by doing this, I went from 60 minutes to 33 minutes. That's all I had to do. Again, just remove the stuff that I was not using. So this is like the 3 steps that I applied. Again, very simple steps. It's not something kind of very hard to do. And you can see now how I managed to reduce the refresh time from 4 hours to 30 minutes, which is a lot, with only these 3 very simple things, which is disable the auto-date time. I improved query folding. I looked at my query folding and tried to put everything in the beginning, so it's folded and sent back to that in that envelope to the database. And I removed everything that I didn't need it, and it was taking a lot of space. And that's it. And a lot of the times that I see like people complaining about, oh, my report is taking forever. Sometimes I look at those reports and I'm like, these little things will hugely improve your performance. You don't even have to go again all crazy and try to check all the steps, all the queries and so on. Just again, work smarter, not harder. You have loads of tools that will allow you to define or look for that bottleneck, and you have a lot of little things that you can do that are not just quick wins. These are big wins that you can do with very kind of simple steps that you can take. So this is kind of my use case. And now I want to talk to a little bit, because again, this is for this use case, but I'm pretty sure that this is not true for every like use case, like a Power BI use case, of course. Like again, sometimes disable auto-date time doesn't do much. If you do the query folding properly, then you don't. If the report is still slow, then probably this is even not your problem. So there are a lot of things, other things, again, that you probably should take or pay more attention to. And I wanted to talk about some of those things, which are a little bit outside of this kind of use case. So I probably heard this one before. I've seen a lot of people thinking or not understanding how DAX works. I think that's the main problem. They don't understand the difference between a calculated column and a measure. They think because everything is DAX, everything is the same. And the thing is, it's not the same. A DAX measure is a lot better than any DAX calculated column that you can build. So again, don't think and don't be this kind of meme. I will just create these 3 calculated columns because it's so easy, and it's like Excel. It's so easy. It doesn't work like that. You really need to think about what you're doing. If you can do it in the source, do it in the source. And why am I saying this? Because the engine that processes this DAX calculated columns, or that this DAX calculated columns are processed after all the data that was loaded was compressed in memory, which means that everything you do in Power Query and so on is evaluated before this DAX calculated columns. So this calculated column does not really participate in that evaluation that Power BI does for the Power Query bit, because it does that evaluation kind of because Power BI is trying to figure out like the best sort order for the compression and what's the best compression that it should use to optimize basically your data model. And as a result, because the calculated columns in DAX they are not part of that compression kind of evaluation, Power BI doesn't really optimize the calculated DAX columns. So again, don't try to do the calculated DAX columns. This is kind of the last resource. So if you don't understand, and then how you do calculated columns, then if you can't do it using DAX, then I have this little kind of chart for you. which is, okay, you want to add a new column to your data model. Fine, let's start here. So the first question that you should ask is, can you do it in the source? If yes, then don't tell me it takes forever and the database is managed by IT or whatever. Do it in the source. It's always better. Push as many transformations as you can to the data source. So again, if you can do it in the source, please do it in the source. Don't do it using DAX and a calculated column in DAX. If for some reason, which might happen sometimes, you can't do it in the source, then the next question you should ask yourself is, can you do it in the query editor? If you can, then okay, do it in the query editor, but be careful with those like the query folding stuff and all of that. Of course, pay attention to that. And if for some reason you can't do it in the query editor, then the last question is, can you do it in DAX? And the answer to both yes and no is don't. Do it in the source. And if you don't understand what I mean, then maybe like this, you will. So again, really try to avoid doing those calculated columns in DAX. Unless your report, you don't have much data, your report is really simple, just don't try to do that. It's kind of, yeah, it will probably ruin your performance. So now, the star schema. So you probably, if you work with Power BI, you heard a lot about the star schema and how it is great to have star schema kind of structure in Power BI. You have like this dimension tables because they support filtering and grouping, and you have this kind of fact tables with the summarization, sorry, that supports summarization. So Power BI loves star schemas. If you don't know that already, then you know now. It loves star schemas. So now, one question that sometimes I get is, okay, but why does it love star schemas? And it's a question that is, for me at least, it is a little bit hard to kind of go into a lot of detail of why it loves star schemas, because I find the easiest way is to show like what happens when you have one big flat table and when you have a star schema. I think that's the easiest way to kind of explain it. Just look at the results when you try to basically run a DAX measure on a star schema kind of data model and a flat table, and you see the difference and you can see which one is better. So I kind of copied this from SQL BI. So this is what this was in one of their blog posts. So they call this the slim data model, which I love the concept, and or slim tables versus the flat tables, or slim data models versus fat data models. So the slim data model is kind of that star schema, the normalized kind of data model, and the fat model is that one big fat table that is not normalized. So here they basically tested this. So they tested what happens when you have a star schema kind of structure, and when you try to use the same data but in one big flat, like a fat table, fat. So I'm not going to read all these numbers and anything. I'm going to jump straight into the conclusion, and I'm kind of going to paraphrase what they've said, because I think it's kind of the best way to kind of understand, or not probably understand, but in a way to check why is the fat kind of data modeling not good. So in conclusion, the conclusion for this kind of study that they did is that by going towards a single table model or that kind of fat table model, you obtain a larger model that performs slightly better on a limited number of simple queries. So actually, they've done this kind of study, and they've done this testing themselves, and they kind of saw that this fat table, huge table, was actually better than the star schema when the queries were simple, very simple, but it becomes very slow as soon as the queries start to increase in complexity. So as you can see here, the same query, because this one was kind of more complex, executed on this kind of slim model, took 1 millisecond. And look at how long it took in the fat model. So this is because the slim model needs to scan a dimension and not the fact table. So it doesn't take that long because each dimension will contain only a few thousand of rows, which is nothing compared to the kind of billions of rows that the fact table has. So in the fat kind of version of your data model, if you have a very complex query, Power BI will have to scan again, think about billions of rows, and it will take forever, probably. Whilst if you have like the slim kind of data modeling, where you have your dimension tables, your fact tables, Power BI won't have to kind of scan those billion rows because you don't have one big fact table. It goes to the dimensions, it goes to the facts, and that's it. And again, in the dimensions, you won't have those billion rows. You have a few thousand rows, and it will be a lot faster. So this is kind of, I think it's the best testing about like why star schemas are good that I've seen. And of course, SQL BI, they are great. And in the end, of course, the slim table or the slim kind of data modeling won this kind of little test that they did. Another thing that I wanted to talk about is the best practice rules analyzer. It's another tool, another one. And this one, this tool basically allows you to helps you of identifying potential modeling missteps that you have, or changes that you can make to improve the model design and performance and so on. So and this includes recommendations for example, for naming, user experience, or common optimizations that you can make to improve the performance. And I have here some of the rules that I wrote down so that I couldn't forget. So you have, for example, for DAX expressions, you have like you use the divide function. That's kind of a best practice rule. And this best practice rules analyzer will kind of tell you, look, you have this measure that is not using a divide function, so you should use it. It will kind of warn you about avoiding using the if error function. So if you use the if error function, you as you can see here, it says like, okay, don't use this if error function and how many times basically you're using it, and you shouldn't be using it. So you have error prevention stuff like rules that for calculated columns must have an expression. Oh, sorry, that's not what I meant. The calculated columns must have an expression. That's what I meant, which makes total sense, right? And you also have like the formatting rules, like adding data category to the columns, you hiding foreign keys, like field formatting, like those 1,000 separators and decimal places. You have other rules like ensuring tables have relationships, very basic, but sometimes if the model is very big, maybe we can forget, and removing roles with no members. And then you have the most important part, I guess, for this, at least related to this session, which is the performance rules. And you have in the performance rules, you have like, I can give you a few examples, like avoiding bidirectional relationships. Many to many should be single direction. You should minimize the power query transformations, reduce the usage of calculated tables and calculated columns, like I mentioned before. And another one, like split the time, like when you have a date time column, split that into two, because again, it's easier for the compression engine to kind of do its work like that, because you don't have as many single values. So it will be easier for Power BI to compress that. So yeah, you have loads of different rules that you can use. And again, that is at least one very big blog post, I think, that will explain everything, how you can use this and so on. So I'm not, again, going into a lot of details on how you can actually use the best practice rules analyzer. Just want to give you some ideas on things that you can use to actually improve the performance, so that can help you improve the performance of your reports. So again, another tool that you can use, and check the blog post if you ever want to use it, because again, they have like tutorials and everything that you can use. Another thing that will increase the performance for obvious reasons, I would say, is the incremental refresh. So of course, when you use incremental refresh, you're not refreshing like your entire data set. You're just refreshing, for example, the last day or the last week or something like that. Imagine if you have 10 years worth of data, of course, it will take a lot longer to refresh 10 years of data than to refresh 5 days, right? So that's how incremental refresh can also help you improve the refresh timings. And of course, and most of the times, you probably can use incremental refresh and probably should. So another thing to keep in mind, you don't have to refresh your entire data model like every time. You can just define an incremental refresh and refresh only the last 5 days, last month, or something similar to that. So another thing that is also related to performance is the performance around the front end part. So we've been talking a lot about the performance more on the back end side of things, like the data model and all of that. But we can't forget like that the front end also has performance issues sometimes. When I mean front end is when you're interacting with a report, sometimes the visuals are slow, they take some time to kind of show you the data or the insights that you need. And usually there are two problems for this. It's either your DAX that is not very good, your DAX measures, or it is your design that is not very good either. So, or it can be both, which happens more times than it should probably. So your main question is it my visuals or is it my DAX? Am I doing something wrong with my DAX? One of the ways that you can, again, check what is the bottleneck of your poor performance in terms of visually is the performance analyzer. I put it in a demo, but I'm not actually going to do the demo because otherwise I won't be able to talk about everything that I want. But in Power BI Desktop, you have this performance analyzer, another tool that you can use. You can run this and check for each one of your visuals what's happening, like what's taking more time. Is it taking more time kind of running that DAX query, or is it taking more time rendering the visual? So you will see, like, if it's taking a lot of time rendering the visual, then that's your problem. If it's taking a lot of time in the DAX measure, then the problem is your DAX. So here again, you can kind of define where you should be looking at. And it's, again, an easy way to define that. So another tool that you can use to do this is this report analyzer, which is kind of new, I think. So the report analyzer is basically, if I go back, this performance analyzer, but it takes it to a whole different level. So this is basically showing you the report, and is the objective of this tool is basically to simplify the process of finding like the visuals that are the problem of your performance, and it aims to do this in more like a visual kind of way, like give you more the visual experience that you don't have with the performance analyzer. And this will, of course, help you also figure out where is my bottleneck, where is the, in this case, it's easier to understand what's the visual that is the biggest problem in my report page. So, and with this tool, you will basically be able to, again, visually see the performance analyzer data, but overlaid like this, in where you have each one of the visuals represented as this little box, and it's kind of a simulation. And then you can find the specific visuals by the visual ID. You can filter this by visual type. You can even filter this by the query time, the DAX query time. So if you want to focus just on the visuals that are taking forever, like the query in DAX is taking forever, you can filter this so you are only looking and you're only focusing on the visuals that are actually like a big problem. So again, it's a more visual way to do this performance analyzer. And of course, if it is your DAX, if the problem is your DAX, then you should probably read a lot of the SQL BI blog posts. If it is your visuals, then some of the things that I see being a problem a lot, and there are probably two main things that will cause your reports to be kind of slow in a way, responding visually. I mean, it's either you're using loads of different visuals, like don't think you can put 50 visuals in a page. That doesn't work. So because Power BI will take forever to render all the data for those 50 visuals. And then another thing is some people really do like custom visuals. They really do like custom visuals. I can kind of understand why, but custom visuals, they are usually very slow. Or I mean, they are not all slow, but a lot of them are very slow. For example, I remember this one was incredibly slow to load the data. Every time you applied a filter, this would just take forever to show like anything here. So again, if you can, please avoid custom visuals, or only use the certified ones. But in general, don't try not to put too many custom visuals in a page, because it will kind of not break, but it will become very slow if you try to use a lot of custom visuals. So, and from my experience, by the way, most of the times, everything you have in a custom visual, if you are creative, you can kind of achieve the same thing with the standard visuals. You have lots of formatting options. If you are creative, most of the times you can do the same thing. So before you go to the store, I think it's App Store, I think, if I'm not wrong with the name, and get all the custom view, before you actually do that, go and check the standard visuals, go and check the formatting options, go and read a little bit online, because again, most of the times, not most, but a lot of the times, you can find your way around with the standard visuals. And again, with that, you will avoid a lot of problems in terms of performance in the front end that is caused by custom visuals. So another good kind of tip, I would say. And now I just wanted to talk to you, my last topic, a little bit about visualization. And this is not necessarily about performance, I would say, but I always like to talk about visualization. But even though it's not necessarily like performance related, I would say, it does impact like how people use your report in a way. So I always like to share this Power BI report design process that I built and that I presented at not SQL Bits, Big Data London. Yes. And this is kind of my kind of design thinking process when I'm building my reports. And I will give you an example on why I'm a meme, obviously, on why I'm actually talking about this, because again, it's not necessarily around performance. So don't try to jump all these steps. That's kind of my main advice, because a lot of the times you have like some people that instead of doing their business analysis, like knowing their audience to find the purpose of why they are building that report in the first place, taking really the time to understand the data that you are working with, get those business requirements right, those technical requirements, get the design requirements that a lot of people don't get, and then define that information architecture, how you're going to present things visually, what kind of layout are you going to use, how are your users going to interact with that report, and then how you're going to bring all of this together, like in terms of what kind of data visualization are you actually going to use to present those insights to your end user. Like the colors, the fonts, images, everything counts. And also, of course, test everything in the end, but don't test just the data, test the design too. Because again, if you do this, your users will notice. And this will probably be a failed kind of project. And again, this is important because it drives adoption. It kind of makes your users trust your report more if you're actually thinking about the presentation and to make your report look professional. Because let's be honest, no one wants to spend, I don't know, thousands of dollars on a tool like Power BI to then people not liking it. I don't like the reports. I don't want to use it. And it's not like the adoption is very low. So that's not what we want like to happen. We want everyone to actually be using the tool. That's why we are investing a lot of money and a lot of time on kind of implementing that tool. So we want our users to use that tool, to get those insights from that tool. So we need to really think carefully, not just about the back end, about performance and data modeling and all of that, but also think about the front end, like what are actually people going to, how are people actually going to use that report? What kind of insights are they getting? What's their perception? What's the perception that they are going to have when they open that report? And why does it matter? I love this one. So I think this is the perfect kind of way to explain why I talk about visualization so much, even though when I'm giving a session, about performance. So imagine this is, instead of a horse, you have a report. And this is what your data, imagine your data modeling looks like this. It started amazing. It's like a beautiful data model. But then this is your report. This is how your report looks like. And now think about the fact that when you publish that report to the service, this is what your users are going to see. So imagine that if it was you and this is all you were able to see, what do you think was here? Would you think it was this? I don't think so. I probably would think this thing, it looks even worse behind the scenes. So this leads to people not trusting your report. If it doesn't look right, then they will be like, if the person building this report clearly didn't take enough time to make it look professional and to make like the report insightful, why would I believe that they took the time to do that with the data modeling? Probably they didn't. That's what probably most people will think. So that's why I like to always talk about data visualization, because again, it's the perception, and you don't want to be spending time and money on a tool when the perception of the people that are going to use it is this, right? You want the entire experience, or what I like to call like the data experience, to be an end-to-end thing. The front end matches the back end and vice versa, and everything looks correct and looks nice. Not nice. Data modeling is probably not a nice thing to look at, but at least the visual bit looks professional. And also, of course, the data model is performant and so on. So, of course, both things are important, because if you have the other way around, if you hide this bit, I mean, I would also think that the visualization would be probably nice. But anyway, the idea here is this is a bit that your users will end up looking at. Your end users are not going to look at your data modeling. So yeah, this is the impression that they will have about your data model. Don't forget that if you give them this, they will think the backend looks the same, and that's not what we want. And I'm not sure how I am in terms of time. Okay, 1 hour. Okay. So this is everything I had to talk about. So that was my kind of last topic that I wanted to talk about, and I just want to thank you all for coming to my session, and hopefully it was insightful, and hopefully you learned something new, especially around all these different tools that I just talked about, like loads of them. And yes, if you ever want to get in touch with me, you can even send me an email. I'm on Twitter, Data Pairs. I also have a website. So yeah, if you ever want to get in touch, just feel free to use any of this kind of methods that I have here. And yes, this is, I think, oops, okay, everything that I had to present.
First of all, let me say thanks a lot for your presentation.
No problem.
I really like the last picture bit. Yeah, it makes sense. That, sometimes you put a lot of effort into the data modeling, and you have a really nice model working perfectly well, and then everything's expected to be that, and you can't find it in the visualization in the end. And, yeah, all the hard work that you put in is actually not seen, or they assume it's not there.
Yeah. That's I think that's kind of the. I found that meme the other day, and I actually was like, I have to use this horse somehow, and then I've done that with. I think it goes really well with just trying to pass that kind of idea. This is the only thing you see, so why would people believe the backend doesn't look the same or worse? It's kind of what people see. So yeah, I think it's the perfect kind of joke, but to explain this in a better light, I would say.
Makes sense. Yeah, makes sense. If there isn't any questions, and I don't see any in the chat.
Hey Mara, this is Kirill.
Hi.
I just wanted to compliment you on emphasizing the business analysis part of the process, right? As a former business analyst, I could definitely appreciate it. People jump straight into modeling or throwing stuff on canvas without doing the due diligence of understanding the requirements, understanding the audience. A lot of what I found in practice is you build one workspace and one app, and all of a sudden then you start realizing, oh my gosh, there's like 3 different audiences for this. Why didn't we think about this? Well, it's because we didn't take enough time to do what you just said. So I appreciate it. Thank you so much.
No problem. Thank you. Okay, I'm not sure if we have questions. I was just going through the chat.
I haven't seen any, to be fair. And I guess people are leaving.
Not.
So yeah, then I'll just quickly share our last slides. Yep, perfect. And thanks again, Mara. That was a really great session. Everybody, if you want to rewatch it, you can find it on the YouTube channel. Please feel free to subscribe if you haven't done so already, and hope to see you in our next session, which will be announced via LinkedIn or in the Meetup group. Thank you. Bye-bye.
Thank you, everyone. Bye-bye.
Have a good day.
Thanks so much. Good day.